Have you ever tried to use an AI tool to summarize a massive stack of documents, like maybe for work or a huge research project, only to watch it confidently invent facts or just completely lose the plot?
Oh, yeah. It happens all the time.
Right. You feed it all this incredibly detailed, accurate information, and it hands you back a summary that reads like it was pulled from a parallel universe.
The very confident parallel universe.
Exactly. A very confident, totally wrong universe. So today, we're going to look at exactly why that happens, and more importantly, how a brand new release is trying to fix it.
Because it is just a universally frustrating experience, especially if you're, relying on that AI to do heavy lifting for your job. You know the information is in those files, but the AI just cannot seem to hold all the threads together without getting confused.
Welcome to this deep dive. Today's Thursday, April 30, 2026. And just yesterday, FalkorDB released GraphRAG SDK 1.0.
Hot off the presses.
Literally. We are pulling from a stack of fresh materials today. We've got official press releases, their GitHub repository documentation, the latest benchmark leaderboards, and some highly technical blog posts from the developers.
And there is a lot to unpack there.
There really is. Our mission for this deep dive is to unpack exactly why standard retrieval augmented generation, or RAG, pipelines are failing spectacularly in production, like why they are just crashing and burning.
Right. And how knowledge graphs actually solve this underlying disease, and why this specific open source release is turning heads across the entire AI industry right now.
Because the stakes here are incredibly high for anyone building software.
They really are. I mean, looking at the sources, a recent 2026 analysis of the industry shows that between 72% and 80% of enterprise RAG implementations are failing to make it into production.
Wait, up to 80%.
Up to 80%.
That is a staggering statistic.
Think about what that actually means in the real world. Companies are spending millions of dollars, right, and months of engineering time only to completely scrap the project because the AI cannot be trusted to give accurate answers based on the company's own proprietary data.
Millions of dollars just down the drain. So let's explain why that is happening and how FalkorDB is trying to rescue those failing projects.
Let's do it.
Okay, let's unpack this. To understand why GraphRAG SDK 1.0 is such a breakthrough, we first need to understand the disease it is trying to cure.
The root cause.
Right. We keep mentioning standard RAG. For the listener who might just use ChatGPT every day and isn't actively building these enterprise systems, what is standard RAG actually doing behind the scenes?
So standard RAG relies on a mechanism called vector-based retrieval.
Vector-based, okay.
Right. Imagine you take all your company's documents, right, thousands of PDFs, emails, wikis, whatever, and you chop them up into little paragraphs, or what developers call chunks.
Just slicing them up.
Slicing them up. The system then turns those chunks of text into mathematical vectors. You can visualize this like coordinates in a massive multi-dimensional space.
Like a giant 3D graph.
Yeah, exactly, but with way more dimensions, and they're organized by their semantic meaning. So when you ask the AI a question, it turns your question into a coordinate too.
Okay.
And it simply searches for the chunks of text that are physically located nearest to your question in that mathematical space.
So it's looking for things that sound conceptually similar. Or, have related keywords.
Exactly. Which sounds perfectly reasonable, right?
I mean, yeah. When you have a small pile of documents, if you're only querying 10 documents, the system looks highly accurate.
But it completely falls apart at 1,000 documents.
Why? Why 1,000?
Because at 1,000 documents or 10,000 documents, you suddenly have thousands of chunks of text that might share similar keywords but have absolutely nothing to do with each other.
Oh.
The mathematical search just brings back a pile of disconnected noise, and this problem gets exponentially worse with what data scientists call multi-hop questions.
A multi-hop question. That's when you need the AI to connect a sequence of distinct facts, right?
Yes.
Like connecting person A to organization B, and then figuring out how organization B is related to event C.
Exactly. You're hopping from one concept to the next. And to answer a multi-hop question, a standard RG system has to perform multiple vector searches, pulling in more and more text chunks each time.
Oh, that sounds inefficient.
It's terrible. It triggers dozens of unnecessary calls to the large language model. It is a phenomenon known as retrieval multiplication.
Retrieval multiplication.
Yeah, you are pulling in so much irrelevant, semantically similar junk along the way. And remember, you have to pay the AI provider for every single word it processes.
Right, the tokens.
Yes. This is why token costs, the literal financial cost of running the AI, run 3 to 5 times higher in production environments compared to isolated testing.
3 to 5 times higher? I always think of standard RAG like a frantic, highly caffeinated intern.
That's a great way to put it.
Like, you ask this intern to find out who signed a specific vendor contract in 2024. And the intern runs to a massive filing cabinet and just starts wildly grabbing files simply because the folders have the word contract or 2024 on the cover.
Just throwing paper everywhere.
Exactly. They run back and dump a mountain of paper on your desk. It sort of looks right, but they completely missed the actual story connecting the document.
They miss the plot entirely.
But wait, let me push back here.
Sure.
If the problem is just that the AI isn't making the right connections, why can't we just throw a smarter, more expensive LLM at the problem?
Because
Like, why do we need to completely change the architecture? Why not just use the newest, most powerful model and let it read the whole mountain of paper?
that is the exact trap most enterprise teams fall into. And it's
Right.
exactly why 80% of them fail.
Really?
Yeah. What's fascinating here is that the problem isn't the brain. The LLM is the brain, and today's LLMs are brilliant, right? The problem is the eyes, the retrieval system fetching the data. If vector retrieval feeds the LLM isolated, disconnected chunks of text, even the smartest, most advanced model in the world is starved of context.
You can't see the big picture.
It simply doesn't have the explicit relationships required to do deterministic reasoning. It is like asking a genius, world-class detective to solve a complex financial crime, but you only let them look at random, disconnected puzzle pieces through a tiny keyhole.
Oh, wow.
No matter how smart the detective is, they can't see the whole board.
So throwing bigger models at bad retrieval just doesn't work.
Not at all.
The architecture itself had to evolve from these flat, disconnected chunks into connected graphs. Enter GraphRAG.
Yes.
How does this actually change the game? Like, what is happening differently when we use a knowledge graph?
So GraphRAG changes the fundamental structure of how data is stored, read, and retrieved. During the ingestion phase...
When you're first feeding the documents in.
Right. When you're first feeding your company's documents into the system, it runs a natural language processing, or NLP, pipeline.
Okay.
This pipeline reads the text and explicitly extracts entities and relationships. It doesn't just store flat text. It stores those extractions as nodes and edges in a graph database.
Nodes and edges. Let's make sure that's crystal clear for you listening. A node is a noun, right?
Yeah.
Like a person, a place, or a company.
Yep.
And the edge is the verb or the relationship connecting them. So person A is a node, company B is a node, and the edge connecting them is the CEO of.
That is a perfect way to visualize it. It looks like a detective string board, you know, with the push pins and the red yarn connecting all the clues.
Classic conspiracy board.
Exactly. So at query time, instead of blindly searching for text chunks with similar mathematical meanings, the system actually traverses these explicit relationships.
It walks along the red yarn.
It walks the yarn. And the results of this architectural shift are undeniable. Microsoft Research ran a comprehensive study on this recently, and they found that GraphRAG achieves 86% comprehensiveness on complex queries.
86%.
Yeah, and standard vector RAG only hit 57% on the exact same data set.
57 to 86. That is a massive gap in performance.
Huge.
But to be fair, I mean, it hasn't all been smooth sailing for GraphRAG either. Looking at the history of this tech in the sources, these early GraphRAG implementations had some serious sins.
Oh, they were very messy.
They were incredibly brittle. The extraction pipelines would actually hallucinate graph edges, meaning the AI reading the documents would just make up relationships that didn't exist.
Fake red yarn.
Fake red yarn. They required months of manual tuning by highly paid engineers just to get them working, and they consumed massive amounts of compute power just to construct the graph before you even ask the system a single question.
Which brings us right back to why teams were burning their compute budgets and failing to reach production. Building the graph was just too hard.
Right.
And this is the specific friction that FalkorDB's SDK 1.0 is designed to eliminate. First off, they made it LLM agnostic.
Which means?
You aren't locked into one specific provider. Depending on your budget and your privacy needs, you can use OpenAI, Anthropic, Cohere, or even run local open source models on your own hardware all through a single interface.
Okay. That's flexible. And they tackle that months of tuning problem with something called a default ontology.
Yes.
Now, an ontology is basically a blueprint for how the database should view reality.
Right.
And FalkorDB built in 11 common business concepts right out of the box. Things like people, organizations, products, events, and roles.
Right.
So instead of a development team spending 3 weeks arguing over how to define a company to the database, they can just use the default blueprint and get a working system in days.
That default ontology is an absolute lifesaver for engineering teams. It gives the AI a structured, rigid lens to view the documents through immediately.
It knows what to look for.
Exactly. When the AI knows it's only looking for those 11 specific types of entities, it drastically reduces the chances of hallucinating those weird, incorrect relationships we saw in earlier versions.
Here's where it gets really interesting, though. There's a feature called dynamic merging.
Oh, this is a big one.
Let's say you've built your massive graph,
Yeah.
but business data isn't static, right? What happens on Tuesday when a new contract gets signed?
Things change.
The dynamic merging feature allows the system to absorb new documents and update the existing knowledge graph without requiring a full rebuild from scratch.
Which saves a ton of time.
But hold on, I have to ask about the downside of this.
Okay, hit me.
If the system just keeps incrementally merging new facts as they arrive, without a built-in way to automatically delete the old superseded facts, doesn't the knowledge graph eventually turn into a digital hoarder's house? Just crammed full of outdated, conflicting information.
You've hit on one of the most critical architectural constraints in data science right now. It is a very valid critique. If you keep pouring data in, the graph gets noisy.
It gets messy.
And looking at FalkorDB's current documentation, automatic removal of outdated facts is currently just on their roadmap. It is not a shipped feature in version 1.0.
Ah, so the digital hoarder risk is a reality today.
It absolutely is. This means engineers working with rapidly changing data, like daily financial reports, they still have to build manual invalidation steps into their workflows.
Manually taking out the trash.
Pretty much. You need a strategy for deprecating the old edges, or your graph will eventually start returning conflicting answers, telling you that two different people are currently the CEO of the exact same company.
Good to know. It's not pure magic just yet. The engineers still have to do some heavy lifting. But let's pivot to where it does look pretty magical.
The benchmarks.
The benchmarks. Because it is one thing to have an elegant theory of connected nodes and red yarn. But if you're an enterprise CTO listening to this, you only care about two things. Does it win on the leaderboards, and what does it cost my department?
Right. And on the leaderboards, FalkorDB SDK 1.0 made a very serious statement. There is a major multi-domain evaluation called GraphRAG-Bench.
Okay.
FalkorDB ranked #1 overall. They scored a 69.73, beating out major competitors like gReasoner, Auto-Pruned Retriever, LightRAG, and even Microsoft's own MS GraphRAG.
And they absolutely dominated the medical data set with a score of 75.73.
Which is incredibly hard to do.
Let's think about why that is. Medical data is incredibly complex. If you have a patient with a specific symptom, taking a specific drug, experiencing a specific outcome over a 5-year period, a vector search is just going to find documents with similar medical words.
Just flat keywords.
But a graph actually maps the timeline and the physical interactions. Looking closely at the benchmark breakdown, FalkorDB's specific leads were in complex reasoning and contextual summarization.
Which perfectly aligns with the failures of standard RA we discussed earlier. Fact retrieval, just finding a specific name or a date of birth, that's relatively easy for flat vector search.
Sure.
But synthesizing context across 50 different medical journals or reasoning through a complex chain of corporate events, that is where walking the graph traversal proves its immense worth.
But here is the ultimate flex from this release.
The hardware.
They achieved these benchmark topping scores running the entire thing on a simple MacBook Air.
It's wild.
An Apple M3 processor with 24 gigabytes of RAM paired with the cheaper GPT-4o mini model. No massive liquid-cooled GPU clusters required.
None. The economics of scale here are exactly what will get those 80% of failing enterprise projects moving again. Let's break down the exact costs from their testing.
Let's hear it.
To ingest a 1,000-document corpus, which they calculate is about 17.6 million tokens of text, it costs only about $5.50 in LLM API costs using that cheaper mini model.
$5. Wow.
And once that graph is built, each retrieval query you ask the system adds just 1/10 of a cent, $0.001.
That is incredibly cheap for the query itself. But I want to zero in on the ingestion side for a second.
Okay.
Because building the graph takes time. The documentation states it takes about 10 hours to ingest those 1,000 documents sequentially. Processing takes 21 to 33 seconds per document.
Yep.
I picture this like a python digesting a massive meal.
That's a good visual.
It's highly nutritious. It extracts all this amazing value from the data. but it is incredibly slow.
Hmm.
If ingestion is the real bottleneck, how on earth is this supposed to be used for real-time breaking news environments or high-frequency trading?
The Python analogy is spot on. It is a very heavy lift up front, but we have to clarify where the bottleneck actually lives.
Okay.
The 10-hour delay is entirely the NLP extraction throughput. It is the AI model taking the time to read, analyze, and extract the entities from the text. The bottleneck is not the FalkorDB graph database capacity itself.
Meaning the database isn't slow to write the data. The AI is just slow at reading the text.
Precisely. So in a real-world enterprise deployment, you would never run this sequentially on a single machine.
You wouldn't use one laptop.
No, definitely not.
Yeah.
Teams have to pipeline their document processing across parallel workers. You spin up 50 or 100 instances to read and extract the documents simultaneously, and they all feed their findings into the single graph database concurrently.
Okay, so you just hire more digital readers to process the documents at the same time? That scales beautifully. So now that we know it scales efficiently from a hardware perspective, how are enterprises actually putting this into production without compromising security?
This brings us to a feature called multi-tenancy architecture.
Multi-tenancy.
Yeah. In enterprise software as a service, you often have hundreds of different corporate clients using the exact same application. FalkorDB allows each tenant to get an entirely isolated knowledge graph at the data layer, not just isolated at the query layer.
Wait, I need to push back on this on a philosophical level.
Go for it.
If the whole magic of a knowledge graph is connecting disparate, unexpected dots across a massive data set, doesn't isolating every tenant's data into its own walled garden completely defeat the purpose?
Wow.
Aren't you just building a bunch of tiny, less powerful brains instead of one massive interconnected superbrain?
You've just hit on the biggest philosophical debate in data architecture right now.
Mm-hmm.
You are absolutely right. A universal brain that connects everything would be infinitely more powerful.
Right.
But the harsh reality of enterprise software is that security always trumps universal knowledge.
Ah, I see.
Imagine a legal platform used by competing law firms. You cannot have the system accidentally traversing a graph edge and leaking a connection between law firm A's shell company and law firm B's active lawsuit.
Oh, wow.
Yeah.
That would be a catastrophic company-ending breach.
It would be over instantly. So the isolation at the data layer ensures that when tenant A asks a question, the traversal physically cannot cross over the boundaries into tenant B's graph no matter what.
That makes total sense from a liability standpoint. And speaking of shell companies, the release highlights some fascinating real-world use cases for this tech.
They have some really cool examples.
There's a regulatory compliance analyzer, which maps internal corporate policies to actual daily workflows to spot compliance gaps. But my favorite is the AML, or Anti-Money Laundering Network Analyzer.
Oh, that one is brilliant.
It traces fund flows across institutions, identifies shell companies, and flags suspicious patterns by literally visualizing the hidden relationships in the financial ecosystem.
It is the perfect application of a graph. Money launderers intentionally rely on the fact that flat tabular data, like your standard spreadsheets, makes it incredibly hard to see the web of transactions.
Because it's just rows and columns.
Exactly. A knowledge graph takes that confusing spreadsheet and turns it into a literal visual map of the crime.
And FalkorDB is expanding the ecosystem around this core database, too. They just released a tool called Query Weaver, which is an open-source tool for text-to-SQL powered by the graph.
Which is super helpful.
For the listener, text-to-SQL means you can type a question in plain English, and the AI translates it into database code automatically. And they've also integrated with Zep's Graphiti framework. This provides sub-millisecond query performance for multi-agent AI memory.
That integration with Graphiti is wild. When we say multi-agent AI memory, we are talking about a future where you have multiple AI bots working together on a project.
AI collaborating with AI.
Right. And they need to be able to recall temporal context, like what bot A did 10 minutes ago and when, instantly.
Right.
That sub-millisecond speed is critical for them to collaborate without lagging. It all points back to the core insight of this 1.0 release. The harness matters more than the model.
The harness matters more.
A well-architected retrieval layer like this graph framework will consistently beat a weak, flat vector pipeline, even if that weak pipeline is running a wildly expensive LLM.
So what does this all mean for you and your projects? It means the era of treating AI retrieval like a simple keyword search is ending. FalkorDB's GraphRAG SDK 1.0 proves about by taking the time to map the actual relationships between concepts, creating those explicit nodes and edges, we can drastically reduce AI hallucinations, lower our token costs, and finally push those 80% of failing enterprise AI projects over the finish line.
It is a profound shift from asking the AI to just read and summarize to asking it to connect and reason. And as we've seen in the benchmarks, that structured reasoning scales in a way that flat vector search simply cannot.
Which leaves us with a pretty wild thought to chew on.
Let's hear it.
We started this deep dive talking about that frantic intern wildly grabbing files out of a cabinet. But if AI systems are moving away from just fetching flat text and are now actively traversing complex relationships, like a digital detective, mapping out shell companies and regulatory gaps in sub-milliseconds,
Yeah.
what happens when these multi-agent knowledge graphs start recognizing macro patterns in human behavior that human analysts are simply too slow or too overwhelmed by data to ever notice?
That is the real frontier. It changes everything when the graph starts telling us about deep systemic connections we didn't even know we should be asking for.
Something to keep you up at night, or at least keep you thinking differently about the data you interact with every day. Thank you for joining us on this deep dive. Keep connecting the dots in your own learning journey, and we will catch you next time.